Can you hear me?
Yes,
Yes,
sir.
sir.
Yeah. See, the second part is, I think the first part is most of the boring, which I don't like unit, but we need to know all these features also. Like then only we can have some understanding of this subjects, because what are their different types of landforms in the ocean, what are different types of shapes and features, characteristics within the oceans. And next is coming the ocean currents and ocean dynamics. You know, ocean currents, you know, plays a very important part. Basically, these currents, ocean currents, because of difference in cooling and heating, this influence total global climate. Okay, so let's understand first, maybe 3 4 slides for the ocean currents. Then I will tell about the ocean dynamics. Okay, you see, for example, how the ocean has a role to play in a particular area if agriculture is affected, whether we can link that with the features that origins from the ocean. In a particular area, there is a very high prone vector-borne disease, malaria or dengue. Whether we can link that with the climate, or is there at all any impact of climate on this type of disease? And even is there any impact of climate on a or like different types of species? For example, bird migration. Birds are migrating from one place to another place. So if we have to understand this, like is there any impact of hydrology, like floods and droughts, or water resource? If we go to the origin, if we find the origin, maybe on the origin we will find this, where is the source of this, if we find a cause behind it, why there is a drought and a flood in a particular river basin. Can we link that to ocean sea surface temperature warming or cooling? This sea surface warming and cooling, the sea surface warming and cooling creates different types of climate variability phenomena. Okay, and this climate variability phenomena that influences particular places rainfall or temperature. More on rainfall. So if because of sea surface warming or cooling that influence the rainfall, and that rainfall influence the cropping pattern and also the hydrology, then there is a clear link of land and ocean interaction dynamics. The land, ocean, and atmosphere, this dynamics is very interlinked. It is a coupled phenomenon. And this coupled phenomena means when there is a sea surface warming in the ocean, in particular area, ocean surface was warming, that warming just more evaporation takes place, and this within this evaporations there are more water vapor there, and this water vapor through zonal wind, takes just away to some places, so and then it condenses and falls in the form of rainfall. That means this influence all this. So when we will study all this climate variability through the ocean sea surface temperature, this ocean current and this ocean dynamics is very, very important. So let's understand this, and I am sharing one uh, PPT. Just Sorry. Yeah. So I'm sharing this PPT. It's very interesting. This part will be very interesting. So let's see. So ocean dynamics, ocean currents and dynamics. Okay. So the general movement of a mass of oceanic water in a definite direction is called the ocean currents. Okay. So without spending more time on this ocean currents, let's also understand. In few slides, I clearly define what are the ocean currents and what are the factors, the origin of ocean currents, and what are the other factors that influence these ocean currents. Then we will go for the ocean dynamics part. The ocean currents are most powerful of all the dynamics of the ocean waters because these drive ocean waters for thousands of kilometers away. You see, El Nino and southern oscillations from Australia to like Peru, west coast of Peru. If you link that, like eastern Pacific oceans and of warming and cooling, El Nino and La Nina. I think, have you heard the term El Nino and La Nina? आप लोग कभी सुने हैं एल नीनो और ला नीना के बारे में?
Yes,
Sir,
sir.
हाँ. और आयोडीन इंडियन ओशन डायपोल के बारे में सुने हैं?
नहीं सर.
अच्छा. और एंसो मोदोकी के बारे में सुने हैं कभी? लानिना मोदोकी, एलिना मोदोकी.
नहीं सर.
Okay. Ningalo Nina? Maybe no. So I think all this phenomenon, like El Nino and La Nina, because it was around 1970s, early 70s, this phenomena has been investigated and properly documented through different publications. Then we came to know. But nowadays also, like IOD was first invented in 2009, sorry, 1999, first time, first paper, Nature uh, came on 2000, sorry, 1999, yeah, somewhere about September, October 1999. So then on the Enso Modoki, it's a similar features but different. That phenomena around 2007, first time it was reported. And this IOD and this Modoki, that influence on the people in different areas of vector-borne diseases and also climate change many impact. And what is this climate change at all? What is this? And this climate variability leads to climate change, and this climate variability, there is a fluctuation. What is variability? The variability means fluctuations. That means there is a difference from the mean, difference from the standard. What is standard? Standard is the average. If from a average temperature or average weather conditions, okay, and there is any fluctuations rises, for example, within a day, if we observe the temperature in a ocean or in a landmass, we can find when it is going to peak and how it falls. Okay, early morning, then after 2 hours, then after 2 hours, similarly, after taking within 24 hours, 12 reading, then we can see within these 12 readings, what is the time gap and when, at what time this temperature is going high and then coming down. Okay, so if you take the average, that will become the average for the day. Okay, but within that day, we have internal fluctuations and variations are there. Similarly, if this variability after 1 day, 1 week, 1 month, if you read all the data every daily wise and it persists, and if you have data more than 30 or 40 years, then with the sea surface temperature data, if you measure how the temperature varies in different seasons and different times, then how this warming has influence in a particular weather pattern. Because when the sea surface warming or cooling influence or attracts, like it's a giving, conversion and divergent zones it creates, and because of that conversion and divergent zones, there are this water vapor comes and sometimes accumulates somewhere and sometimes diverges, and condense in another place and forms in a form of rainfall. So this landfall, sea surface temperature warming and cooling has direct influence to the rainfall or precipitation pattern in a place. So that if sea surface temperature warming and cooling influence all this, then it has other parameters also influencing cropping pattern, influencing hydrology, influencing the, like as I told, vector-borne disease, and many other parameters also, like forest fire. It has also influence in a ecosystems services. So all this is linked to the somehow the ocean warming, and along with the natural features of a other way of rainfall, what is normally land and sea breeze, that is there. But apart from that also, this ocean surface warming and cooling also influence. So I will talk also this, like how it is influencing. On the basis of temperature, ocean currents are divided into two types: warm currents and cold currents. So what are the origin of these ocean currents? The characteristics of ocean water. What are the origins? Because of the characteristics of ocean water. The second is rotational mechanism of the earth. Then atmospheric factors. And fourth is topographic characteristics of coast and ocean basins. These are the factors, four factors that influence, that have some origin of currents. Why there is a currents origin in the oceans. These are four factors. Okay, so how this first factor, characteristic of ocean water influence this, like creation of origin for a ocean currents. So yeah, temperature variations is a bigger role in the ocean water. Then salinity difference. This, because of the temperature variations, also there is influence like salinity. So that salinity difference also have influence on the, like current creation. So then pressure gradient. These three things are there within the like characteristics of the ocean water that influence also the ocean currents. Then what are the second factors, like rotational mechanism of the earth, like gravitational force, okay, and deflection force of the earth's rotation, like coming closer, apogee and perigee, that concept also, like because of apogee and perigee there is tides or tidal waves also increases and decreases, and there is a spring or nip tide because of also these factors. So there are rotational mechanism of the earth's Cureless force and all this. So this also has some gravitational force that also influence, and because of that also ocean currents are there. And also another factor is seasonal variations. Seasonal variations because of different seasonal, like amount of solar radiations falling on the earth in different way, different seasons. So that also one reason of creation of different types of origin of ocean currents. Okay, also a factor for that. And third factor is atmospheric factors, like atmospheric pressure and winds, that also plays an important role. Then evaporations, okay, and precipitation. These are the atmospheric factors. Then another fourth factor is topographic characteristics of the coast and the ocean basins. So like direction and shape of the coastline within the topographic features, how these topographic features have origin. It's one of the factor for origin of the currents because of shape and direction of the coastal lines. Okay, that also creates these ocean currents. very like elongated, very narrow, and very wide ocean base and something. So it varies as it varies also the like horizontal and vertical upwelling movement of water also that like propagation, that wavelengths and varies based on the coastal size, direction and shape of the coastline. So then bottom reliefs of the ocean basins also. These are the topographic features that characteristics that influence that are the factors of origin of currents. Then primary force and effects of ocean currents. The ocean currents are driven by the following factors like solar heating, winds, gravity and Cureless force, and effects of ocean currents that transform heat from tropical to the polar regions and influence weather and climate that distribute nutrient and scatter organisms. Right? Because of these ocean currents, what are the factors that influence within the ocean? Because of these ocean currents. So ocean currents origin are four factors, and within that all these factors are one by one, that is I have discussed here. Then these ocean currents are driven by the solar heating, also winds, gravity and Cureless force. And this, because of this ocean current effects, there are transfer of heat from tropical to polar regions. Okay, and also from one region to another region, how this uh, currents are traveling, I mean going from uh, one point to another point. So that's why enso, this enso, as you know, El Nino and La Nina, you know, El Nino and La Nina, these features along with southern oscillation. Enso, El Nino, La Nina and southern oscillation. This southern oscillation, you see, Darwin, Tahiti to Darwin, that range of uh, like transfer of heat and ocean currents that when mixed with this on like eastern specific warming like El Nino that generates both in combine. It's a couple phenomena like ENSO, this with El Nino and southern oscillations. But these El Nino positions, location of El Nino, where it happens in the eastern Pacific coast, west coast of Peru, to this southern oscillations, which is near just north of Australia, that is Darwin, to west of it, like Tahiti. So this area, so this sorry, east of it, Tahiti. So that's total belt is how it is creates this propagation of El Nino southern oscillations, and that influence the weather and climate. How these ocean currents influence the weather and climate. Okay, and then distribution of nutrients and scattered organisms, that also ocean currents also distributes like the different types of nutrients. Because of the nutrients also different types of aquatic life in a particular region that is available there, like we have famous fishing ground Dogger banks because of available of nutrients, that is warm and cold currents mixing zone, and because of that there are more phytoplanktons are there. Because of that there is a very good uh, fishing ground. So different types of organisms also affected by that. So what is solar heating? So distribution of solar heating is not uniform. Okay, and the equator receives more heat than the polar regions, and this solar heating causes water to expand and move. Okay, when in a particular area like equatorial zone, if more I mean solar radiation it is getting, so obviously the equator receives more heat than the polar regions. So this solar heating causes also main factor, one of the factor, it becomes origin of one of the factors for ocean currents. Then wind is caused by the pressure gradient force, and pressure gradient force results in a net force that is directed from high to low pressures, and this variation of pressure is caused by differential solar heating. One is linked with another, and this Cureless force modify the movements of the world, creating the globe wind belts, different types of wind belts. You know, where is roaring 40s and horse latitudes and all this. You see, we have high and low pressure zones. I think in the climatology you have understood this, like how all other and like different types of zones are there. Okay, wind belts are there. So surface currents are wind driven circulations, that is there. This is also happening in the sea. Then gravity. So pull water downhill and pile against the pressure gradient, that is high and low. Upwelling, we also sometimes we call it, like in the area where land and sea is coming, and then water is coming, and within the sea also the water cycle is going like upwelling through upwelling. Uh, they maintain also different types of nutrients also that generates because of this upwelling. And upwelling have also certain areas where it is happening more. So causes of geostrophic current together with cureless force is also another factor that influence this also currents. Okay. Then what are the cureless force? Caused by the Earth's rotation faster at the equator than at the poles, which changes the intended path of all moving bodies, winds and currents, and motions are deflected in the right of the in the northern hemisphere and left in the southern hemispheres because of the gyre, in the ocean and ocean beds. This from the gyre, this is the pattern of, how this gyre has been created. See, and the Cureless force, and all because of this influence, and we have now gyre, that huge circular moving current systems, large wheels of water within an ocean basin. Okay, you see how in different gyre has been created different area because of you see somewhere elongated, and location and distribution, the special location of different types of like different oceans plays a major role in which area there is a gyre. You can see also in the oceans. So see in the Indian Ocean, and see also there is a gyre in the North Pacific, there is a gyre in the South Pacific, North Atlantic gyre and South Atlantic gyre. Okay, and five main gyres are there. North Pacific gyre, which is clockwise, and South Pacific gyre is counterclockwise, and North Atlantic gyre is clockwise. Then South Atlantic gyre is counterclockwise. Indian Ocean gyre is counterclockwise. So, see these are main five different types of gyre formation in the ocean, and this creates the wind pattern. You see the one, the westward flow of equatorial surface wind produces anticyclonic current gyres. Okay, they start with north equatorial and south equatorial currents in the Atlantic. You can see 1 and 2 in red symbol, 1 and 2 in Atlantic Ocean. This was created because of the west flow of the equatorial surface wind. Okay, and you see in the second.
Excuse me, sir.
Yes, good. Yeah.
Sir, your screen note is visible to us.
What? You
Sir,
can
your
see.
screen.
You can see PPT.
No, sir.
Since when you can see PPT?
About 10 to 15 minutes.
Why? But why didn't complain that just working? Why is everything is working? Just wait. Just wait. I think somehow lost. Now we can see.
No, sir.
Can you see now?
No, sir.
Not yet. No.
Yes, sir. Yes,
Okay.
sir. It's visible now. Yes, sir.
Oh, okay. So you see this gyre I was talking about, and how this Indian Ocean North specific gyre. I will share also this PPT with your host, so that after the class also you can get it. Okay. Yeah,
Yes,
I will
sir. That
keep.
would be great.
Yeah, I will share this PPT with your host, and I will through email I will send this both the class PPT, so you can see also after the class. There's no problem. Okay.
Okay,
Yeah.
sir. Thank you, sir.
Yeah. So see these 5 types of gyre, and these 5 main gyres like north specific gyre, which is clockwise. You can see all these gyres are there with the arrow. You can see which is clockwise, which is counterclockwise. And here I am talking about like when the westward flow of equatorial surface winds produce anticyclonic current gyres. They start with north equatorial and south equatorial currents. In the Atlantic Ocean, you can see 1 and 2. This is in red. And then specific 3 and 4, south equatorial current in the Pacific Ocean and the north equatorial current in the Pacific Ocean, 3 and 4. And then 5, the south equatorial current in the Indian Ocean. You can see this, I mean, already there, how this equatorial range, these currents are forming. Okay. Then within the ocean, the western flow of equatorial surface winds produce anticyclonic current gyres blocked by the land. You see, 1, 1, 2, 3, 4, 5. Then you can see 6, 7, 8, 9, 10. 6 is somewhere eastern, east side of Japan, and 7th is east side of Australia, and 8th is the Atlantic Ocean, just it's on Caribbean Sea, just in the West Indies side, and 9th is just in the eastern side of Argentina. So you can see, and 10th is the Madagascar, eastern side of Madagascar. This westward flow of equatorial surface wind or anticyclonic gyre. Because of this, when it goes towards this like 1 and 2 and 3 and 4 and this 5, this equatorial currents, then it, because of the land mass, it just blocked and these currents turn polewards. Okay, because of that land is there, so it block and becomes poleward, went to the poleward. Some 6 and 8, but 7, 6 and 8 went towards the north pole, but 7, 9 and 10 that went towards the south pole because of this land blocking there. So then you can see this again, they cool down as they reach up to 45-degree latitudes and return as cold water currents. You see how these currents changed. Okay, total dynamics. Try to understand. First, 1, 2, 3, 4. This equatorial in the Atlantic Ocean, equatorial in the Pacific Ocean, and equatorial current in the Indian Ocean. If you understand 1, 2, 3, 4, and 5, 1, 2 is in Atlantic Ocean. That means north equatorial current, south equatorial current in the Atlantic Ocean. 3, 4 is the north equatorial current and south equatorial current of the Pacific Ocean, and within Indian Ocean it is south equatorial current. Okay, so when all this you understand, then when it enters like touches in a land area, it blocks and then turns towards the poleward. And for the 6th and 8th, okay, that went towards the poleward of northern hemisphere pole side, and 7, 9 and 10 towards the southern side, and then they cool down as they reaches to the 45-degree latitude and returns as a cold water. You see, then 11, 12, 13, 14 and 15. The blue color is cold one that returns. Okay, that means 13 is California current. You see, 12th is 11th is California current, 12th is Peru current, and 13th is Canary current, and 14th is Bering currents, and then West Australian currents. Okay, all these currents you can see, and then you see here again. They also call the west wind drift. This cold water current is the only ocean surface current that joins the waters of all the oceans. Okay, these currents are coming, upwelling, and this you see the circum-Atlantic circulations. This range, the cold currents are coming from polar regions of both sides and also connecting to horizontally, going from horizontally from the both sides. You can see entering from the west towards the east direction. It is going. So all these currents you can clearly see. And this again, this equatorial counter current is the gravity-driven rollback of warm waters stacked on the western margin of the tropical oceans by westward flowing equatorial surface winds. This you see, this equatorial counter currents, ECC, in between 1 and 2, 3 and 4, and you can see just above 5. This ECC, like equatorial counter currents, because of landmass then coming back. Okay, this also is factor creating this ECC can trigger El Nino. This is a factor that has triggered this El Nino, creation of this El Nino. Okay, and if all these current characteristics you understand through the different types of gyre, how this forming, and it's very clearly here I have presented how is cold and warm currents. You can name all these currents also, the major currents. There are many small currents also there. That is you can locally driven, but these are more like specific Atlantic and Indian Ocean currents that plays a major role. Okay, so if we talk about these ocean currents and how these ocean currents has influence, you see, if you know that how you will define weather and climate, okay. So these currents and ocean dynamics, ocean surface interaction with land and atmosphere, with coupling phenomena. That means one phenomena happens in the ocean, that is sea surface warming, surface temperature warming in the ocean, that has linked with with atmospheric phenomena, so ocean atmosphere. Then when it enters to the land, ocean atmosphere and land, or land ocean atmosphere interaction, within these three coupled phenomena, these all different types of climate variability phenomena we have, and that governs the global climate. Okay, so before going to that, like how this climate variability in different types of, then it talks about this to 2021, around within these 20 years, 16 years we have recorded ever warming temperature, warmest year ever in the earth. That means ever recorded temperature
Sir,
within
your
20
screen
years.
is not sharing.
Sorry,
Sir, your screen is not sharing, sir.
why again? Automatic it is going down and down. I can't understand. Is there any problem? Now you can see.
Yes, sir.
Okay,
Yes, sir.
okay. Did you see earlier one also like this? All this equatorial. You understood this?
Yes, sir.
Okay. So this climate, like the climate variability I'm talking about, how this climate change when we are talking about, whether they have also a link to the sea surface temperature warming. The climate, as you know, is the average weather conditions, and this weather It's defined as physical state of the atmosphere at a given point of time at the globe. And according to WMO, World Meteorological Organization's recommendation, a period of 3 decades, we can have a standard period of estimation. Then after that, we can say it's climate variable or variability or climate change is happening. See, what is the sea surface tide? And this sea surface warming temperature has influenced different types of climate variability modes. Like in the North Atlantic Ocean, it is North Atlantic Oscillations, NAO. And then within specific ocean, it is specific decadal oscillations. Also, it is a climate variability phenomenon. And monsoon, we have another climate variability phenomenon. Then Madden-Julian oscillation, it is another climate variability phenomenon. And then we have El Nino Southern Oscillation, and also Indian Ocean Dipole. Then El Nino Southern Oscillation like Enso Modoki. All these are also different types of climate variability phenomenon. And these climate variability phenomenon are happens in the only because of difference or variability, or there is a fluctuation in the observations of sea surface temperature in a particular area. You see what is ENSO? Okay, the ENSO means El Nino. Here is the La Nina. The schematic diagram, ocean atmosphere conditions related to El Nino and La Nina. What is happening in El Nino? The eastern Pacific Ocean, the west coast of Peru, getting warmer, particularly from December, January, February, that period. Okay, it's Christ-styled because it develops from like around Christmas time. So it's generally this warming of temperature starts in December, January, February. So this eastern Pacific warming, okay, of temperature is El Nino. That influence, like because of warming, you see evaporations, that means it went through the water vapor, and this through zonal wind, when this sea surface temperature warming linked with the zonal wind plays a characteristic role, and this takes water vapor from the sea, because sea is a huge, Pacific Ocean is very big, and there is a huge water vapors because of this warming, and these water vapors are going because of zonal wind, and then it condenses and then forms in the form of rainfall. So this has different global impact. Similarly, the La Nina, just in the same western coast of Peru, uh, when the western Pacific is cooling, that is La Nina. The eastern Pacific Ocean, particularly the west coast of Peru, when it's more cooling in the normal. So that means that time also this wave like is coming. One is convergence zone, then another is divergence zone. So this is El Nino, that is La Nina. So this happens, and because of this, what are the characteristics? For the first time, ENSO phenomena has been explained by Jacques and in 1969, and it occurs in the specific ocean or specific basin-wide warming. Also, it is known as basin-wide warming, because specific ocean wide warming, because of very wide area it is warming. So it is also known as like specific basin-wide warming. It occurs in the specific basin in every 2 to 7 years. I mean, once it happens, then maybe in the coming next year, sometimes it do happens then next year also, but it range like 2 to 7 years. So the features of the events vary from event to event, because the intensity of heating or cooling, the intensity of heating and cooling, because of that intensity of heating and cooling, the event varies from one to one. Okay, so this event, when it becomes like very dangerous, sometimes because of creates some area, it's like very uh, drought and flood. El Nino and La Nina impacts the world climate differently, depends upon the intensity and duration of the phenomenon. In the USA, Mexico, Kenya, Tanzania, Zambia, Zimbabwe, Mozambique, Botswana, Southeast Asia, India, China, and all these parts. Okay, Australia, Northern Europe, Malaysia, Philippines, Indonesia, and Brazil. See, many area it influence. And this, the Enso Modoki, after Enso and El Nino, then a new type of El Nino with warm, cool waters in the central equatorial Pacific Ocean. See, what is happening? Modoki. when there is ENSO, and what is ENSO Modoki. Again, it is also because it generates, it propagates, starts from the ocean warming, variations in the ocean warming. But in case of El Nino, the eastern specific is warming, and in case of Enso Modoki, the central specific is warming. Central specific is warming means it is eastern and east and west side of central specific is cooling, but the central part of ocean is warming. That is similar, just similar type of ENSO phenomena, but it's a totally different one. Because how it difference? Because in case of ENSO, only eastern specific is warming, but in ENSO Modoki, the central specific is warming. Same specific ocean, but central specific. Because of it, from the study, it came to know that because of global warming and other different factors, this warming of eastern specific just pushes towards the central specific. And when warming shifts towards the central specific, then the eastern and western specific within that area, they become cooling. So this creates another phenomena. It's known as Modoki. It's a Japanese term which means similar but different. Similar, quite similar of Ensu type phenomena. It is in the specific, but it propagates. It starts from September, October, November. It's generally El Nino starts from December, but Modoki starts like warming of temperature starts from September. Propagation starts from September, October, November. So, and similarly, in the La Nina Modoki, in the La Nina Modoki, the specific ocean central part is cooling, and eastern and western part of the specific ocean is warming. That phenomena is known as La Nina. So, La Nina Modoki. So, this Modoki has been coined by Professor Toshio Yamagata of Tokyo University. First time they published a paper in the Nature, and he have coined this term Modoki in 2007. This paper was published. So he coined the term Modoki as a Japanese term, which means similar but different. So characteristic of several studies have shown that the Enso Modoki has become more prominent in recent times, and it is changing the teleconnections pattern arising from the tropical and specific. Teleconnection means the ocean and the atmosphere interactions. That teleconnection part, it has changing. It changed the teleconnection part. It is not just similar one. It's a different one. Because of that, it occurs in both boreal summer, June, July, August, and also boreal winters, December, January, February. Sorry, I forgot. It's not in September, October, November. That is IOD. IOD propagates in September, October, November. I'm sorry for that mistake. And Indian Ocean Dipole, again, after this. So this, and so Modoki is boreal summer, June, July, August, and also boreal winter, like December, January, February. It starts similarly. That's why it is in more similarity, but there is a difference because of occurrence of special occurrence of heating. Okay, the Enso Modoki events significantly influence the temperature and precipitation over many parts of the globe. Okay, that is Japan, New Zealand, west coast of United States, India, Southern Africa, South Africa, sorry, China and Brazil. These parts also it has influence. Then in the Indian Ocean, these are very recently developed, Enso Modoki and IOD, Indian Ocean Dipole. Like in the early 70s, what they have found in the Pacific Ocean that El Nino and La Nina features are there. Similarly, in 1999, this same group of researchers from Tokyo University along with Jamstack, this Toshio Yamagata group, he was the leader of PI of that group, and they have found that in the Indian Ocean also there are two types of dipoles of warming features are there. You see, in the Indian Ocean of Bay of Bengal side, in the Madagascar, east of Africa, Madagascar side, this is positive IOD. Cooling is happening in the Indonesia side, and warming is in the Madagascar side. That means western of Bay of Bengal, western side of Indian Ocean, and warming and cooling of eastern side of Indian Ocean. Then you see how this wave propagates. That means when Madagascar side is warming, that means more water vapor will go. I mean, it will go upward. So when it will go upward, then the current from the Indonesian side will flow towards the Madagascar side. So this is known as IOD, positive IOD. That means this is a positive IOD. Similarly, like El Nino and La Nina, it is also negative IOD. Negative IOD is the just reverse of this positive IOD. When the Madagascar side is very cold and warm, sea surface temperature is very cold, I mean ocean temperature is very cold, cooling, and Indonesia side is warming, Indonesia to Australia, that side is warming. That means the current movement changes, like from it went from African side towards the eastern Australia side or Indonesia side. So this is known as negative IOD. Okay, this propagates normally in September up to November. So the dipole mode index is derived from the SST anomalies by taking difference between the western and eastern tropical Indian Ocean. And this IOD phenomena was first identified by climate researchers in 1999, and IOD has functioned since at the least the middle of the Holocene period. There was another study in the Nature also, it was published in 2007 also, like IOD phenomena was there in the Holocene period, 6,500 years before what is there. So there the IOD influence the climate of Eastern Africa, India, Bangladesh, Vietnam, Indonesia, Australia, Europe, Japan, Korea, and also East China. And the social impacts of climate variability modes. And this, like how the different types of Asian modes has been influenced in different types of Asian region. There are more and various papers I have published. I mean, if you can just type my name in the Google Scholar, you can find all these papers, research papers are there dealing with this type of climate variability phenomenon like IOD and Sumodoki. I tried that phenomenon. I had established a link. That means if sea surface temperature warming and cooling influence the rainfall of a place, that means it will definitely influence the water or the water, that means water resources or hydrology of a river basin, runoff of a river basin. So I try to establish the link that that time when I did my PhD, it was in 2009. I just enrolled, started. You see, 2007, the first time IOD was there, investigated, and first time it was reported in Nature. Then 1999 it was IOD. 2007 it was Modoki. So when I took PhD, just registered for my PhD at Kyoto University in 2009, I took the challenge, this IOD and this Modoki, a very new phenomenon. So whether that has any influence of a drought or a flood condition on a river basin, that was my first research questions that arise in my mind. That means if ocean dynamics are there and ocean currents are playing a role, if sea surface temperature governs the ENSO phenomena, and that means because of sea surface temperature warming and cooling that have creates the El Nino and La Nina, that also governs the different types of weather phenomena in the global different countries. So similarly, the Modoki and IOD also has some influence in different types of weather in different countries. So to establish that link, I tried to take the challenge. I first investigated this other the stream flow events, low stream flow events. That means stream flow means river discharge. Low river discharge events means drought. This drought of Citarum River, it's an Indonesian river. So I first tried if IOD is there, whether IOD, any river within this Indian Ocean rim countries, the countries which are residing within the Indian Ocean, their river systems are influenced by this Indian Ocean dipole movements, positive and negative IODs. So I find it was very clearly established and it was published in 2012 as a PhD paper in very prestigious journal, which is Climate Dynamics. So that means I successfully linked that. I captured the signal through my research in the that the IOD has influenced the river basin. That means even the river basin is only 12,000 square kilometer area. That means IOD, that means global phenomena, and a big global phenomena like IOD or ENSO, Modoki or ENSO has influence in the hydrology, drought and flood. If you can predict IOD, that means we can predict any future drought or flood in a river basin. So accordingly, the policymakers and other agriculture practitioners and water resource managers can be, get the information and they can prepare for their post condition is coming. So if there is any, because of that IOD drought or flood will come, maybe you will have some shortage of water somewhere, maybe some excess of water somewhere, drought or flood for a river hydrology. And then after establishing this phenomenon, this is for IOD events. You can find this paper. You can just Google Scholar. You can put and you can find this paper in 2012. You can just type my name in the Google Scholar and you will find that, and you can have a read on that. Second is I just try to same thing like Modoki. You see here, you see this is red color Eastern Pacific, and this here it is Indian side. It is positive IOD. Okay, Western Pacific Madagascar side is also warming, and this is both IOD and also El Nino in this figure. But here you can see the specific central specific is warming. You know, these signals I capture also taking the data from a river discharge point. Both the case, Indonesia case also, I took the data from a river discharge data every day, daily basis, river discharge data, and I capture successfully the signals. So similarly here, the Brazil case also, I from the river discharge data, I try to capture the signals like how to link that with the atmospheric circulations, like outgoing longover radiations, zonal wind. You can find in this figure there are some arrows are going. These are showing the direction of winds. Okay, there are also contour lines. You can see the contour lines. So all these things like stream arrow and this OLR shaded part is SST, sea surface temperature. So that means sea surface temperature, warming and cooling also influence a river basin's drought and flood. And that drought and flood also influence the water resource management systems of a particular, area. So if this is one of the study, then after that I tried if it is influence this climate variability or sea surface temperature warming, ocean warming or cooling influence the river hydrology. Of course, it will influence the agriculture productivity. So then I extend my study also for the different types of agriculture productivity. For Orissa or Bihar, again I started doing research whether this sea surface temperature warming has any influence on the rice productivity in Bihar or any Orissa. Just where I get the data, I just started working on it. I'm also working on other parts. So I find that paper was also published in Sustainability, another good journal. So like impact of Indo-Pacific climate variability on rice productivity in Bihar. So what I'm trying to say here, the oceanography, the ocean, and another also paper I try to find very good link on Mahanadi or another from Orissa, like Mahanadi River also, because I get the data, discharge data, so I started studying that, and I also find some ENSO phenomena along with the monsoon, Indian monsoon climate variability that has influenced drought and flood in Mahanadi. So this paper that is published already in the Water Journal. So you can find impact of Indo-Pacific climate variability in extremely high stream flow events in the Mahanadi. So there are many such papers and works you can find also globally. Many people have done different types of work that how this ocean dynamics plays a major role. And now I extend my studies like how this sea surface temperature warming, because that propagates different types of climate variability, and that climate variability phenomenon like ENSO, IOD, or Modoki that influence the vector 1 disease like dengue and malaria. And for Delhi, already paper has been published, like this climate variability phenomenon influence the dengue cases in Delhi. And also for Orissa part also I had done another study like Kalahandi. So there are many studies still I am going on, many studies I am going on, like how this uh, sea surface temperature warming, ocean dynamics, land, ocean atmosphere interaction phenomenon, this coupled phenomenon. It's not a single phenomenon of atmosphere, it's a single phenomenon of ocean. It is land, ocean, and atmosphere interaction. Because ocean surface is warming or cooling, that warming and cooling, and because of that warming and cooling, it evaporates. That evaporation contains water vapor. That water vapors carried away by the wind. That wind when it carried away, sometimes somewhere it is condensed, and where it is condensed more and falling at the rainfall, that area is more flood, and where there is no condensation take place, or that area, that country is supposed to be a drought. So this is, if this is happening, then it has a direct link with the river basin. So river basin also, if it has influence in the river basin, let's check why dengue is happening only in a particular season. So then that question raised in mind, if dengue is happening in a particular season after the rainfall, that means pre-monsoon or post-monsoon rainfall, then of course there is a direct link of this sea surface temperature warming. So you can extend your study also. There are different types of climate variability phenomenon, and they have the different links. So all these factors happening because of ocean currents and ocean dynamics. And you can also, after graduations, if you do a master's or a master's dissertations, or also for your PhD, MPhil, you can do and take very, very interesting studies also for this. So if any other things related to this type of ocean dynamics or currents, all these things you want to study, find and just search my name in the Google Scholar. All this paper you can download freely. There's no money will be asked, because some journals, all journals, whatever they are available in PDF form, I have uploaded that, and you can Google Scholar, you can find and you can read for detailed knowledge about this ocean dynamics and how this Indo-Pacific climate variability influence the hydrology, even health, even rice productivity. So I'm exploring also other areas like this uh, climate variability or influence in temperature and precipitation also influence the bird migration. Now I have extended this study also like different national, like we have bird sanctuaries, or taking the bird sanctuary data through RTI. I am analyzing this whether this bird migration like Bharatpur bird migration of Rajasthan is now why I know cranes, Siberian cranes are not coming nowadays. After 2002, 2003, the Siberian cranes are not a single Siberian crane is coming. So when I analyze the primary investigation data, so I try to find that because of rising temperature and different other factors also, I am working on it. When I will finally work on that, I will publish another paper also on that topic. So for you, this oceanography with the ocean topography, different types of features, what are the ocean characteristics, what are the salinity, ocean types, and all this. This dynamics, ocean currents and dynamics of land ocean atmosphere interaction is very, very unexplored part. This is very, very interesting part also. This is very challenging. If you take the challenge, you can publish your paper. So with that, today, I mean, this is the last part of my lecture. If you have any questions, you can ask me if you have any doubt.
Thank you so much, sir, for your wonderful lecture. Uh, If anyone has question, please write it in the chat box, or you can directly ask.
No question? Okay. I think maybe they, I mean, just couldn't get it or effect. Okay. So, okay. You see, what is the Cureless Force? Why we are talking here the Cureless Force? Because of rotation and all these factors, how accurately the sonar works. Okay, so you see one by one. Okay, somebody is asking, is it 100% accurate? Very, I mean, good questions, like curiosity of mind. Yeah. Also, when I was a student, I had the same questions, like whether it is this propagation works very well. So through the sound echoing systems, how can we measure the length and all this? But so far, it is working, and maybe it's, I can say it is 100% accurate. But we don't have other options also. Like even if nowadays we have remote sensing and other techniques, but still advancement of this sonar techniques are also within the sonar systems. Many other techniques of propagations and how much time it is taking and coming, and whether they are targeting in a particular area. Once in a particular area it is coming, then from that area they try to you know retake. I mean taking again and again, then simulating it. So through technology, now it is little easier to do that, but still it's not, I can't say it is 100% accurate, but it's, we have the near accurate. For example, like early warning systems, accurate prediction of a nowadays, even IMD, we have a very good techniques of early warning systems nowadays, particularly after super cyclone in Orissa 1999. When super cyclone happens in Orissa, that was around 10,000 people died. Okay, and many properties all of this thing lost. So then, taking this note, NDMA, National Development Disaster Management Authority, along with IMD, they started working on the proper accurate of early warning systems, of how they can accurately, you know, access the cyclone, how low pressure area created, when it is created, and how long it is there from the coastal area, and what is the speed of this wind when it will come and touch us, and how long it will take. All this type of early warning systems now it is more accurately they are doing, but still, where the landfall will happen, sometimes the area fluctuates still today. See, we are approaching that is near accuracy, but sometimes it differs. It happens even for the case of USA, NASA also receives, because it's a natural system. It's very difficult with the technology to do all this type of minute analysis. Okay, and second, Cureless Force. When I'm telling here the Cureless Force, that is basically talking about that how these different types of wind belts has been created because of Earth rotation and revolutions. Okay, the westward and eastward movement, all this because of this Cureless Force, this wind belts has been there. So that wind belts also within the sea or equatorial range, that influence there. Okay, you have studied maybe Cureless Force in the form of wind climatology, but here also different types of wind belts because of Earth's rotation and revolutions, that different pressure belts creates, and that pressure belts has different types of wind belts. We have starting from the equatorial towards the polar in the northern hemisphere, and also starting from the equatorial towards the polar in the southern hemisphere. That has here on that context, I told that when the wind, origin of wind we are talking about, or origin of currents, also there in the Earth's rotation plays an important role, and within that Cureless Force is there. Okay.
Sir, I would like to ask a question.
Yeah.
Sir, what is the short, medium, and long-term impacts of COVID-19 pandemic on ocean sustainability?
On ocean sustainability.
Yes,
What
sir.
was? Sorry. Pandemic, COVID, yeah.
Sir, what is the short, medium, and long-term impacts of COVID-19 pandemic on ocean sustainability? Sir, ocean is स्थिरता पर
Yeah, yeah.
COVID-19 का.
You see, one very recently, also last year, I worked on a topic like whether this, because of this lockdown period, water quality on a river or in a lake particularly based on a tourist place, whether there is any water quality is changing or not. You know the interesting factor that in India, the major rivers, Ganga, Yamuna, and Brahmaputra, and all these wells, even southern rivers. During the lockdown periods, there was measurement and no water quality. There is no improvement of water quality in these rivers. Okay. So, but during this lockdown period, the air quality changed because of vehicular pollution stopped because of that. So when we are talking about long-term, short-term, and immediate-term impact of ocean sustainability, because of, I mean, lockdown period, maybe in the certain specific areas, like in the coastal area, people didn't go to the have different types of activities, natural resource extractions. Maybe small level it is, I think, maybe short term during 3 months or 4 months or 6 months if it was area was lockdown. Maybe we have short term analysis from a local level data will tell maybe there is some sort of uh, no pollution or oil exploration or something, you know, fishing activities are not, I mean, happening. But in the long term, I think there is no major impact on ocean sustainability because it's during this pandemic period. Even if we are not going through the sick and other moments are uh, stopping, only certain period aquatic lives, maybe certain period locally it is good, but it's not like in the long term. We can say if we will lock down totally, that means it will be we will have a good sustainability of a ocean because we have also other natural phenomenon somehow and other. We all the um, canals and all these rivers links with the waste waters, and these waste waters are going somehow the oceans, and many garbage and plastics are there already. It is a dumping ground, already become a dumping ground. It's such a dumping ground that it will be not very easy, even if in the lockdown period it is not can't have a give a good result. But and above all, how long you can have a lockdown period because of pandemic? Maybe some locally level data analysis, maybe it is short term. You can say something positive is coming. Maybe oceans, other aquatic life and other features are improving, but it's not. I mean, for the whole period, you can't stop this lockdown and you can't extend this. So population are so huge. That means extraction will be there and always it will be dependent on the ocean. So I think long term there is no benefit. I think. That is my personal opinion.
Thank you, sir.
And we can't control that also for the long term without exploration of ocean. There are many in the geopolitics also. You see South China Sea case, all extraction of natural resource for extraction of natural resource. There is almost a war kind of situation is there because of intervention of China and all these other countries and USA and all factors. This is all always is a matter of power and money, and those who are investing more, they are getting more resources from the ocean. So that process will continue also. Maybe for short term, it is locally, it is ocean. Features are improving. Aquatic life may be improving in a local factor, but it's long term. I can't see any good result. Any other questions?
Yes, sir. Okay. Thank you, sir. I request Sohail Khan, sir, for vote of thanks. Sohail, sir.
Thank you, Kizar. It's an honor to have been asked to offer a vote of thanks on the occasion of this super lecture series in our department. On behalf of my department, I, Suhail Khan, faculty of School of Social Sciences, along with the entire management group, here extend my hearty gratitude, and I want to thank from bottom of my heart to the speaker, Dr. Netrananda Sahu sir, for sharing their valuable time and knowledge with us. And I want to thank all that support that you made to us. Thank you, sir.
Thank you. Thank you
And
for bearing your time and listen to me. I think, I mean, yeah,
welcome,
okay.
welcome.
It was a nice interaction with the students. Yeah.
Thank
Okay,
you,
bye.
sir. And again, I want to thank Honorable respected Professor Rekha Acharya ma'am, head of the Department School of Social Sciences. Ma'am, you have been a constant support and you have given us a lot of encouragement. Thank you very much. Uh, and I want to mention and extend my thanks to Mr. Satyam Samraat Acharya sir, who always help us in carrying out such events and seminars all the time. Thank you, Satyam sir. Uh, and also want to thank the host Kizar Khan and all the student coordinators for making their lecture smooth and listening all the time. Thank you, all of you. Uh, and last but not the least, I thank all the students for showing their interest in the program. Uh, I once again thank everyone for making this program successful. I'm sure that our college will continue to get significant provision from the diverse group in the future. Thank you. Thank you, all of you.
Thank you. Okay.